So in this session, we want to look at an extension of the previous problem that we have seen. So instead of finding the first index, we want to find the last index. So you're given a list. And in this list, you want to find the last occurrence of x. That means if you have x here, and x here, you don't want to find the index of this x, you want to find the index of last x. Okay, so in the previous session we saw how to find the index of the first occurrence of x. So that's what we need to do. Now one easy way of doing this is that in the previous session we started looking from here. We were looking if x is here, then we are making a smaller list, and then we are going in this way. The easiest solution will be that you look at the last element. If the last element is x, you return the index of last element. Otherwise you start shortening your list from this direction. So instead of saying this, you will be saying this. So my list will be getting smaller from the last element. But I don't want to do that, right? That's not the purpose of this particular problem. What I want you to do is shorten the list from the beginning only. Okay? So what were we doing last time? In finding the first index, we were trying to check if you have x here. In case you have x here, you will just returning the index of this particular place. Now it was 0 in case you were trying to break the calling smaller list, or it could just be the start index, right? It's possible it's the start index. Any case, you were looking if the first element is x. If it is x, you were not looking in rest of it and you were just returning. You can't do that now, because even if you have x here, you need to keep looking, because if there is an x later, you need to give preference to the later one. In the previous problem, we had to give the preference to the first one. Here we have to give a preference to the later one. So even if you have x here, you can't stop. You need to check if you have x here. And if there is one, then you need to return that last index and not this one. Okay? So let me repeat it again. What I'm proposing is, for now, let's not worry about start index or whether we are making the list smaller or whatever we are doing. Let's just focus on the problem. Okay? Let's not worry about how exactly we are going to implement it. Let's just focus on the problem for now. So, because in the previous problem we had preference to the first element, we were checking the first element first and then calling on rest of the list. In this problem, let's call on rest of the list first. If this returns a -1, that means you don't have x in this part of the list. Only then I will check here. Because in case rest of the list says, hey, I have an x at index 5. Why do I even care if there is an x here? I don't have to check if there is an x here. I'm only going to check if there is an x here if I get a -1 from rest of it. Because if there is already an x here, I don't care about this anymore. Okay? Base case, exactly same. If length is 0, we can return -1. Hypothesis, the smaller list will return the correct last index of x. Step, first call search or last index on smaller list if small output is -1, only then check the starting element. So we'll first call on this. If this returns -1, only then we will check here. Otherwise, we'll return whatever is the output from here, we will return that. Now, I would recommend you to write this code both ways. First of all, making smaller list, then using the start index method that we used earlier. Okay, do it both ways, and then I think you will get a lot of clarity on how exactly to use recursion with arrays. Okay, thank you.